Okay, so we are going to be looking at types of reactions. So the first type of chemical reaction that we're going to be looking at is called a synthesis reaction. And a synthesis reaction means that you're synthesizing or building something more complex from simpler substances. So basically, for the most part, what happens in a synthesis reaction is you're taking two simple things, perhaps two elements, and you're combining them together to form a compound. So if you look down here, here's an example of a synthesis reaction. I'm taking element calcium, reacting with an element oxygen, and it forms a compound, calcium oxide. So I'm synthesizing a compound from two separate elements. Same thing on this side. Element plus element gives you compound. So you have to be able to, of course, recognize or distinguish a synthesis reaction from the other reactions that we're going to be looking at. So let's take a look. Now, if you take a look at, let me give you an example of a synthesis reaction. If you take a look at this very quick video, he's taking a piece of magnesium and burning it.
And record the reaction in your lab reports.
Notice what happened. So what you notice there is, of course, that when the magnesium was heated, it reacted with the oxygen in the air and it formed a compound, magnesium oxide. So that was an example of a synthesis reaction. And after watching the demo, what did you observe? Well, probably the most likely thing that you saw, obviously, was the light that was being given off. And the light being given off tells you, of course, that one, it was an exothermic reaction. Not that it gave off heat, but it gave off light. So exothermic is a reaction that gives off any form of energy. Also, one of the things that tells you it was a chemical reaction and not simply a physical change was the fact that you saw light being given off. So one of the tips that you have a chemical reaction occurring is that light is given off. So for example, when you're burning a piece of wood, in addition to heat being given off, light is also given off. That tells you that burning of wood is a chemical reaction or a chemical change and not a physical change. So let's balance this equation at the bottom. You're going to notice that's a synthesis reaction. You have magnesium and you have oxygen. I have one magnesium and two oxygens on the left side of the arrow and one on the right side. So obviously I need to get two oxygens. I'm going to have to put a 2 here. That gives me, basically that tells me I have 2 of these. So now that tells me I have 2 Mgs and 2 oxygens. So I need to change the magnesium because the oxygens are good. So I simply put a 2 here. This 2 has nothing to do with the oxygen because they're separated. It's now a balanced equation. If you want to do the sum of the coefficients, it would be 2, 1, and 2. So the sum is 5. That's an example of a synthesis reaction. Here's a couple more, and just to save some time, I'm not going to go through the whole process of that. Doing the chart. So I'm going to balance it, so I need to put a 3 here, and a 2 here, and a 2 here. And that would give me a total of, for the coefficients, 2 and 3 is 5, and 2 more is 7. Okay. Next one, this is an easy one. I got to put a 3 here and a 4 here. That would give me 3 carbons. 3 carbons. 4 times 2 is 8 hydrogens. 8 hydrogens. The sum of the coefficients would be 8. Those are all synthesis reactions, and there's a couple more in your notes which you can finish up, and if you have trouble, you can ask me about them. But let's take this one step further. What about if you weren't given the chemical equation as you see it here? Instead of the symbols and the formulas, what about if they gave you a word equation, meaning they don't give you the formulas that you have to work with. You have to, before you can balance it, you actually have to figure out the formulas. Well, here's the equation. Here's the word equation. It's in sentence form. It says iron and oxygen yields iron oxide. Well, remember, yields is the arrow. So that separates the reactants from the only product that you have. Iron is Fe, And remember, oxygen is one of the Brinkelhoffs, so when it's by itself, it's O2. And then iron 3 oxide is iron. Now, I know you're tempted to put a 3 here since that's a Roman numeral 3, but that's not the case. The iron is a +3. That's what that 3 means. And we know oxygen's a -2. So in order for these to cancel out, you're going to need 2 of these and 3 of those, because 3 times that is -6. 2 times that is +6. They cancel out. So the formula is Fe2O3. So now let's balance it. It doesn't matter what element you start with. I'm going to put a 2 here. That'll give me 2 irons. Probably going to have to change it. Notice I have 3 and 2. So I got to put a 2 here, because remember what that gives me. That gives me 2 of this. So now I have 6 oxygens. I only have 2 on this side, so I got to put a 3 here. It also gives me 4 Fe, so I got to go back and change this again to a 4. So the coefficients are 4, 3, and 2, so the sum would be 9. Okay, and there's a couple of these on the next page. And again, I'm not going to take a lot of time to do this, but you can do these at home. And here's the answers. The sulfur trioxide is SO3, and it's going to be 2, 3, and 2. So the sum would be 7. That's not chromium. That's copper. It should be Cr. Plus oxygen again. Chromium 3 oxide. Again, that should be Cr. Well, this is all messed up. Let me just go through this. I didn't catch that when I went over it. So this should be Cr. And this is going to be Cr2O3. So this is not the correct thing. Okay? So when you balance it, it's going to be a 3 and a 2. And this is going to be a 4. So the sum would be 7, 8, 9. And that is synthesis reactions. And